What is the biggest number? We have some pretty big numbers. A googol, that's 1 followed by 100 zeros. A googolplex, that's 1 followed by a googol zero. Even Graham's number, a number so large that if each digit was the size of a single atom, it would be larger than the entire observable universe. But we can make a bigger number. Just take Graham's number and add 1. We can always add 1 to anything and get a bigger number. Or can we? To answer that question, we have to ask another. What is a number? One way to define a number is as the size of a set. A set is an unordered collection of objects. 3 apples, 2 bananas, an apple, a banana, and an orange. In math, sets usually contain numbers. A subset of a set contains only some elements of that set. We can compare sets by looking for a one-to-one correspondence between them. If there is a correspondence, the sets are the same size. If not, one is bigger. We can use this to find out if there is a biggest number. Let's look at the set of natural numbers. This set goes on forever. We call the size of this set infinity. Let's add one more element to this set. This is the same as infinity plus 1. Is that number bigger than infinity? No. We can find a one-to-one correspondence between them. Map 0 to 1, 1 to 2, 2 to 3, and so on forever. Because they will match up forever, both sets are the same size. So, is infinity the biggest number? To answer that, here's what we call the power set of natural numbers. A power set is a set of all subsets. The power set of natural numbers contains 1, 2, 3, 7, all the even numbers, all the primes, and every other subset. I'll represent elements of the power set like this, with a filled-in circle if the number is in the set, and an empty circle if it isn't. The size of the power set is also infinity, but it's a bigger infinity. Let me show you. Let's match up the set of natural numbers with the power set of natural numbers. If they're both the same size, we should get a one-to-one correspondence. Let's match up this subset with 1, this with 2, this with 3, and so on. This goes on forever. But even though it goes on forever, we can always create another subset not on the list. Here's how. Look at whether 1 is in the first subset. If it is, 1 is not in our new subset. Otherwise it is. Do the same for 2, do the same for 3, and so on. This new subset can't be the first subset because 1 is only in one of them. It can't be the second subset because 2 is only in one of them, and so on for each subset. Thus we have a new subset not on this list. With this method, every time you try to find a correspondence between the set of natural numbers and the power set of natural numbers, we can always come up with a new subset not on this list. This means that the power set of natural numbers is bigger than the set of natural numbers. Even infinity isn't the biggest number, because there are multiple infinities. In fact, there are infinite infinities, because for every infinity, we can take the power set and get another one that's bigger. So, what is the biggest number? As you may have suspected, there isn't one, but now you know why.